All right, part 2 on the homework. It's a very similar idea. It's just presented to you differently. So it says, if the tangent of A is 5/3, find the value of the other trig functions. Hint, you're going to use the trig ratio to create the triangle. Okay, so first thing we know is that the tangent of A is 5/3. So I'm going to make my triangle. If we're talking about tangent of A, that's the point of reference. So I'm going to sort of use that like my theta. It's a right triangle, and if they're saying that the tangent is 5/3, well, we know tangent is opposite over adjacent, which means opposite to A needs a 5, adjacent to A, not the hypotenuse, but adjacent to A needs the 3, because this is opposite and this is adjacent. So in order for us to be able to find the other trig functions, we need to know all of the sides, and we don't know all the sides, so we have to find the hypotenuse. So we're going to find the hypotenuse. And by doing that, we're going to be using our Pythagorean theorem. A squared plus b squared equals c squared. So 3 squared plus 5 squared equals x squared. 9 and 25 get us 34. And when you take the square root of 34, you can't simplify it, so it's just going to stay the square root of 34. And that is our hypotenuse. So what we are finding is the trig function. So we're finding the sine of A, cosine of A. It might be helpful just to put in the tangent of A just because you already have it. And then we need cosecant of A, secant of A, and cotangent of A. So if the tangent is 5/3, we know the cotangent is 3/5. It's the other 4. So the sine is opposite over adjacent. Opposite over hypotenuse. So we get 5 over radical 34. Now remembering back to our square root days, we cannot have a square root in the denominator, which means you need to rationalize. So we are multiplying top and bottom by the square root of 34. So we have 5 radical 34 over 34. And that's the answer you get. Now, for cosecant, I wouldn't go to the actual simplified version. I would go back to the original one that you had written. So we originally had wrote that sine was 5 over radical 34. Because that's an issue, but the reciprocal of that, if we flip that, radical 34 over 5 is not an issue. So absolutely, could you take the simplified one, but then you're going to have to re-simplify it. So it almost makes sense just to go back to the original way that you had written it out. Cosine is adjacent over hypotenuse, so very similar idea. 3 over radical 34. Again, rationalize it. And you end up with 3 radical 34 over 34. And then the secant, if you go, this is what we wrote for cosine originally, so the secant would then be the reverse of that, or the reciprocal. So all of your fractions should always 100% be simplified completely, so just make sure that you are not leaving them with radicals in the bottom. That should never be the case, and you should never leave things, say, like we did in the first example. If you can simplify them further, make sure that you do that. All right, what I would do is I would pause the video and see if you can try second one or the third one on your own, just because it is just like the one we went over, and see if you can get it. All right, so whenever you come back, I'm just writing this here. So we have sine in this case, which is opposite over hypotenuse. So 5 over 8. So we have to get the missing side. Get missing side, which is our adjacent side in this case. So we have x squared plus 5 squared equals 8 squared. That gets me 8 squared equals 39, which means x is radical 39. And that's the adjacent side. So a very similar situation that we just had. So we're getting the sine of b, which we have, 5 over 8, cosine of b, tangent of b, cosecant of b, secant of b, and cotangent of b. Okay, so if the sine is 5 over 8, then that means the cosecant is 8 over 5. That one we can do. For cosine, cosine is adjacent over hypotenuse, so that puts us at radical 39 over 8. Well, that's okay because the radical is in the top. But for the reciprocal, if we flip that, we get 8 over radical 39, which then needs to be rationalized. So just make sure that wherever that radical ends up, if it's in the denominator, that you do in fact get rid of it. And you get a radical 39 over 39. For tangent, it's opposite over adjacent. So that's 5 over radical 39. Can't have that, so we're going to rationalize. And you end up with 5 radical 39 over 39. Now again, for cotangent, you go back to the original one you had written here.